Great. So I'm really happy to be here today with you. I'm Valentin Deleplace. I'm a developer advocate for Google Cloud Platform. And today I'll be talking about classifiers and British clay, which is a really enigmatic title. So first, a little bit of storytelling. When I was a kid in the 90s, there was this really great movie in the cinemas. And it was a clay animation stop-motion movie. And one of the characters was a penguin. And in the plot of the movie, the police was actively looking for a dangerous criminal penguin. And at the end of the movie, the penguin, he removes its comb, which is not actually a comb, it's a red rubber glove. And then it's revealed that, so that's the rubber glove, and it's revealed that the penguin and the chicken had been the same character all along. Maybe I'm mixing a little. That was the chicken? Okay. So that one, the police is actively looking after it. It's a dangerous criminal chicken. And actually, the penguin and the chicken are the same character. It's revealed at the end. So my point is, if a rubber glove is enough to make the anonymity of a penguin, then these little black rectangles should be enough to protect the true identity of my two heroes today. Here they are. So, do they look familiar to you? Okay, great. For the sake of protecting their true identity, today I'll refer to them as Wallace and Gromit. That is purely arbitrarily, of course. Okay, back to the slides. So I'll start with a demo. So today we are going to build classifiers of pictures. And why am I doing a demo right now? Because it will take a few minutes to train a model. So what is it about? It's about, let's see, Google Cloud AutoML Vision. So I'm already a user of Google Cloud. Here is the console. I'm going to select now Vision, which opens a new tab. Okay. Let's get started with AutoML. And to build a classifier, what I will do is to click on a new dataset. So I will upload some pictures to train a model, and pictures and labels. So what do they look like? The pictures look like this. No? Okay. They don't look all black, only the eyes. So those are pictures that I will label as being Gromit, and I have other pictures being labeled as being Wallace. I put them all in a zip file. Okay, here I have a zip file. So I give a name to my new dataset. Let's call it WG. Upload the zip file, so it's really easy. Okay. Then I do check, okay, maybe you can't read very well, okay. I do check the checkbox, enable multi-label classification. It's important to me because maybe in the future I will want to infer labels with pictures having both Wallace and Gromit, so it's not mutually exclusive. Okay, create dataset. And this might take a few minutes for no obvious reasons. But in the end, the result will look like that. I just prepared one just in case. Okay. So it will tell me some warnings about importing image. Warnings are mostly about duplicates, but I knew I would have duplicates because some of my pictures feature both Wallace and Gromit. So here I have dozens of photos, like 200 photo or 300 photo total, and some labels. The labels are there on the right side. This one features both Gromit and Wallace. So we'll get back to that later. Okay. So classifiers. What I just did is importing a zip. It was easy because in my zip I had folders, and each folder is supposed to be the label applied to the pictures. So I just had to import it and click Start Training. Okay. Machine learning options. It's a spectrum. At the high level, I put Vision APIs. It's already available in Google Cloud Platform and in several other competitor solutions. What is it? You drag and drop a photo, and it tells you what it sees in the photo. It's a lot about telling you hot dog or not hot dog for any kind of pictures and give you generic insight. But it's really generic. So if I give it a picture of myself doing parachuting, it will correctly infer that with a confidence of 98% it's parachuting. It sees some sky and it sees some cloud, which is technically correct. Okay. But we have a problem. Maybe it's too generic. Let's say I have pictures of lemons, and it correctly infers that this looks like lime or lemon with confidence over 90%, and the one below looks definitely like lemon with very high confidence of 99%. But maybe I can't use this data because maybe my business is a lemon farm, and I'd be more interested into some information like, is this ripe or not ripe? Ripe meaning it's ready to sell and to consume. So this would tell me for the image here that it looks like 30% ripe, and so mostly immature. And the one below is 95% sure being ripe, meaning I can sell it in the market today. Okay, so my point is the inference is much more useful when it's actionable. Here are a few examples. If I have a quad sources images platform and some user is uploading an inappropriate picture, and you all know what an inappropriate picture looks like. I don't have to show samples. So this is really actionable. You just delete it right now. You don't need other users to see it. You don't need children to see it. So it can be very useful to have a detector of inappropriate picture, and it's already available in out of the box in Vision API services like the one in Google Cloud Platform or other competitors. Maybe I'm in a factory and I take a picture of the next item, and it looks like an item that is supposed to go on conveyor belt number 4. This is really actionable. It means tell the robot to take it and put it on conveyor belt number 4. Okay. Another sample is this fruit doesn't look ripe enough. It's supposed to be a lemon, but it looks green. This is really actionable. It means don't sell it on the market today, put it aside and sell it and wait for tomorrow. Okay, so what I need is a custom model and custom labels. I have a domain, I have a business, and I have to build a classifier specific, custom to my needs. So on the very low level, I can achieve this by building a neural network from scratch. So this is kind of difficult and expensive. It requires a large team of data scientists and software engineers, highly skilled, knowing some high-level and low-level programming languages, maybe frameworks or no frameworks. It requires a lot of design, code, time, money, and then a large training set. Neural networks are by far the most popular technology to build classifiers. So if you want to design a neural network from scratch, it will be long and expensive. Okay, we don't have that much time, so I will be quick on some slides. Please pardon me. The second option is to use TensorFlow to build a model from scratch. So this will require fewer data scientists, fewer software engineers. It will still require some design, code, time, money, and to use TensorFlow. Then still a big training set. It's very important to have many examples because it's supervised learning. You need many pictures with the right answer, with the right labels. You shove that into the training in order to set weights inside the neural networks. And in the end, you get a model that you can use for inference. Okay. Third option is to use TensorFlow for transfer learning. Have you heard of transfer learning? Just a few people. Okay. It feels like magic. I mean, it's really convenient. What is it about? It's about having a model, a neural network that is pre-trained with tons and millions of data, of pictures, of forms, many things. And then to get a custom model, you just train the last hidden layers on the right. You put your data between the pre-trained model and the custom model that you're currently training, meaning you get to benefit from all the training that has already been done on millions of objects, recognizing color gradients, recognizing edges, shapes, etc. Okay. And this is possible with TensorFlow. So you have an existing model. You can find some free online, and it's also a business by itself to sell existing generic models. Then you retrain it, just the last layers on the right, with your data set that makes sense for your business model, for your domain, and you get a model. Okay. So the options 1, 2, and 3 requires quite some programming, and the option number 5 is not specific enough. The question is, does it exist a number 4 that would combine the best of both worlds? So being as easy to use as Vision APIs, but as powerful as building a neural network from scratch or with TensorFlow. And that's where AutoML comes into play. So how can AutoML help? Basically, it's supposed to automate everything that is automatable. So you still have to identify a problem, something to be answered. You still need to gather and pre-process data. We'll get back to this in the next slide. But AutoML will help you with splitting data with a training set, let's say 80% of the pictures, and then a test set or validation set. It takes 20% to validate the model and tell you the accuracy scores. We'll get back to that too. Then it builds a model, it trains the model. It can take a few minutes for a small model or many hours or even days for very large models. And then it deploys model because it can host the model ready to infer as a hosted service, like in ML engine, for example, in Google Cloud Platform. And then you just use it to make predictions. So there is still work to do, and I cannot overemphasize this. You still have to gather data, a lot of data that is interest to you. And this is still a lot of human time, and this is not automated by AutoML. So you still need a few data scientists or software engineers to do that work, to gather and cleanse the data or the pre-processing, so to make sure it makes sense for your use case, and this is not automated. Okay. So what does the input data set look like? It's a bunch of pictures and labels. You need at least 100 pictures for each label, and low resolution is fine. On the right, you see a blurry lemon. It's far enough in resolution to train a model. That's why in my demo, I just uploaded like 300 low-resolution pictures. So the zip altogether is 3 megabytes. 3 megabytes of data is enough to train a model. And a big challenge is the UX, and the DX, developer experience. When I said it's trying to automate everything that is automatable, it means that the next challenge is to make it as easy to use as possible for a developer. And several competing solutions have different UX and different DX, and we'll see that in a few slides. And then the end of the demo. Okay. So the question is, how can I provide a training set? So uploading pictures is kind of easy, but how can I upload pictures and the label for each picture? So there are different ways of doing this. You can expose a REST API that the developer will need to call with a curl or with the client libraries. You can say, I want the labels and the name of the pictures in a CSV file, so a tabular file that comes together with the picture by themselves. And so different competing solutions have different UX to provide the input set to AutoML. And then all the rest is pretty much automated. A few minutes later, you just get a model that is ready to infer. Okay. So a small review of existing tools that I've tried on Wallace and Gromit. One is Machinebox. It's a British solution, perfect for Wallace and Gromit. And the tool to build a classifier is called classification box inside Machinebox. So what does it look like? You go to the website, you create an account, okay, you get an API key, and then it's no more a web UI. It's a service that runs locally on your workstation in a Docker container. So first it pulls a few data to build the Docker image, and then everything happens locally in this container. So this is what the payload looks like to create a model with labels, Wallace and Gromit. You call it with curl. Okay, so that builds an empty model, an empty shell. Then you use curls to steal the REST API to train it with some picture. Here, train pick one. What is it? So basically, it's a file in which one picture was base64 encoded. So I shove it into the training process, and it answers success true. Okay, it correctly ingested one picture. Then I make a bash script to range over all my pictures and train them. Okay. Nothing very fancy here. And then my model is ready for inference. And once again, I can just use curl to make a JSON REST request to make an inference. Infer.json here is a payload that contains just basically an image encoded in base64. This image that kind of looks like a dog. Precision, I know you've been eating and you've been hearing some serious stuff in previous talk. I try to make this as relaxing as possible for everyone, so sometimes I'll just ask to upload. Be nice, just upload in this case. Okay, so what is the answer to this post request? It says it looks like Gromit with confidence 80%, which is correct. Please upload Machinebox. Okay, amazing. So I have 4 competing solutions, so I'll be quickly iterating over them, and we'll be discussing some aspects of this inference process. Another one is Microsoft Azure Custom Vision. So it's entirely possible to use it only from the web UI, which is really nice. So first I create a Microsoft account, an Azure account, then I go to Custom Vision, I create a new project, I call it WG. I say it's for classification, multi-label, so the same as in the Google demo. I mean, I say one picture might match several labels. And then I see that in domains, I have options to download the models, some lightweight version of the model, if I want to do some inference directly on the mobile phone for iOS and Android. I did not use this option, but it's really nice to know that the resulting model is downloadable. Okay. So next, I just upload the pictures in the UI. It works really well. It's easy because when I create label Wallace, I just have to drag and drop all the Wallace pictures, and I create label Gromit and upload all the Gromit pictures. It takes no time. It's really fast, which I like. Okay, then it's training. It's also really fast, the training phase. I mean, it's like less than 30 seconds. So for that matter, faster than the Google solution. And at the end, it tells me I got these statistics, 86% recall and 92% precision. Are you familiar with these terms, recall and precision, which I will define right now? So it's the accuracy and the performance of my model, not in terms of speed, but in terms of relevance. So if I have 86% of recall, for example, for the Gromit samples, it means that in the test set, in the validation set, when there was 100 pictures of Gromit, 86 were correctly detected as Gromit by the model, okay? So it's among all the true positive, how many % were correctly detected by the model. And precision is something else, is when I detected Gromit 100 times, out of those 100 detection, how many were true positives? So 92% means that in 8 out of 100, we incorrectly detected Gromit. It actually didn't feature it. So these recall and precision always come together, and depending on a threshold, you can see here a threshold of confidence of 50%. If I want to be really sure about each prediction, I can slide the threshold closer to 100%, which would increase precision and decrease recall. And on the other side, if I don't need to be sure about my hits, about my findings, I can have a low threshold, let's say 20%, in which case I will have a very high recall, but also poor precision. Okay. So in customization, then I will try the inference service. It's all in the UI, and it's a nice UI. So I give it this file, and this file was not part of the training set, and it was also not part of the validation set. It's a picture that the system has never seen yet. Okay, and it says it looks like Wallace with high confidence 99%, and a little bit like Gromit 2%, so way below the threshold, which is correct. Please applaud Microsoft Custom Vision. Thank you. Then I tried with this picture of a dog, which it detects as Gromit 99% confidence. Correct, I like this. Then I try this, a little bit more difficult, in a picture that features both Wallace and Gromit. What will it say? It correctly detected Wallace with high confidence, and it didn't correctly infer Gromit because the confidence here is only 12%, below the threshold. So I don't know exactly why it's harder for it to detect the two in this photo, which basically is the same as previously, but in one single photo. But it turns out it's not always obvious how to train a multi-label model. Okay. Then if I try with something unrelated, it's still anonymized to protect its true identity, of course. So this one is inferred as being Wallace with 93% precision, which is incorrect. I'm sorry, Microsoft Custom Vision, that was not the right answer. Okay, next tool. Clarify is another competitor. So as a machine box, they don't have a web UI to train models. It's all based on client libraries for 6 languages. The 6 languages being JavaScript, Python, Java, C#, Objective-C, and PHP. And there is a curl option, which I'll be using right now in the screenshots, of course. So first, I add a few concepts. What's in my script is a JSON payload, and so this is remote. I mean, everything happens in the cloud. So I just add one image with a concept, and it tells me, okay. So I make a bash script to range over all my pictures and import them, okay. It's still not part of a trained model. I just imported my pictures. Then I create a model. It's another JSON payload. It tells me, okay, and here is the ID of my model. Then I train the model. So the script is really easy. It's just a curl post request to the REST API. It tells me, okay, and here is the model version that I just trained. Okay, I have a model. I can do some inference now. So it's a predict REST endpoint. And because JSON like this is not really legible, I will use GQ on that one. Are you familiar with GQ? So it's a command line tool that pretty prints JSON, much nicer than this one. Okay. So if I predict what this one looks like, it correctly predicts Wallace with high confidence. Correct. Please applause. Clarify. Thank you for them. Okay. So next prediction. This one looks like Gromit with high confidence, 99%. Correct. Then the two, so it correctly detects Gromit with high confidence, and it doesn't correctly detect Wallace because confidence is only 29%. So it's the opposite of earlier. This one, Gromit was detected, but Wallace wasn't. So as I said, it's not always easy to train a model that enables multi-label prediction. Okay. Then with someone unrelated, I didn't say his name. So this is also detected as Wallace with very high confidence. So once again, not an easy job to be 100% accurate on everything. So then the fourth competitor is Google Cloud Platform AutoML Vision, and I can return to my beta because while I was talking and talking and talking, I think it had enough time to train the model. So let's see. Did I actually? Okay, no, I didn't actually click on the train model, so that's a fail. But I'm someone really careful, so I have an already trained model already. Okay, so the UI looks like it. Once I have 300 photos, and which one is that? Okay. Okay, I can click on Start Training. Okay, it will require less than 1 compute hour, which comes for free with the beta version of AutoML Vision. It decides for me a model name. Okay, whatever, it's fine. Start training. And then it would train the model, and it would take like 14 or 15 minutes, which I'm not going to wait just in front of you. So going back to my data sets, what do I have? WG_C, this one should be already trained, but it's exactly the same that would if we had waited for the 15 minutes. Okay, I can use it to predict something. And the UI is similar to the one of Microsoft. It's web-based and really nice. And of course, it also comes with a REST API and some client libraries because in the end, you're interested into integrating those workflows in your application, not to just do online prediction with the mouse, of course. So if I upload this one, what does it say? I hope it's warm. I'm not sure about that, and that would be a pretty big fail for a demo if my model was not warm yet, meaning I would have to wait for like 1 minute and come up with some dancing or I don't know what to fill in the blank. I should have prayed the demo gods. But this proves this is a real demo. It's not a screenshot. It really failed in front of your bare eyes. But I'll be back to this one in a minute and it should be fine. Back to the slides. Is my model ready? Well, I forgot to train the model, so technically the answer is no. My other model was already trained, and technically it was not warm, meaning technically no. Sorry about this demo, this is a really big fail. Okay, recall versus precision, according to the threshold, so that's basically what I was saying earlier. Recall meaning how much of the answers do I actually find? If there is 100 Gromits to find, how many will I catch with my model? And precision is like collateral damage. I mean, if I said I found 100 Gromits, how of all those hits, how many are really Gromits? So this is the definition of precision. Okay, it's An important question is, should I do some single label or multi-label classification? That's for the training phase, because in the end, I will be interested into making multi-label detection. I want to be able to upload a photo featuring Wallace and Gromit because they are really good friends. They often come together. And if I just upload photos containing only Wallace and photos containing only Gromits, at the end, the recall and precisions are not that great. But if I also insert pictures that contain both of them, and I say this picture features both Wallace and Gromit, then I have the same precision, the same recall, but a better precision, which is useful. And what was I saying? I'm lost. Okay, multi-label. Negative examples is a tricky question. Is it useful to upload a bunch of unrelated pictures that don't feature Gromit and don't feature Wallace, just in order to get better precision and recalls? And it turns out that at least in AutoML Vision, in the Google tool, it is useful, because if I train the model with just pictures of Wallace and Gromit, this guy is detected as Wallace with high confidence. But if I upload 200 unrelated pictures, including some pictures of clay animation characters, but that are not Wallace and that are not Gromit, then I greatly I will upload them with a synthetic specific label that I will call none of the above. And then the system correctly infers that this guy is none of the above, meaning not Wallace and not Gromit. And same with the other solutions we've been reviewing. It would be very useful to also train with negative examples. Okay. That's what the inference REST API would look like. So we would get an authentication token and then post some JSON payload and get some prediction. You can use client libraries to integrate with your application running on whatever, App Engine or Kubernetes engine or whatever your system is. And it's usual when you're one of these languages, it's more convenient to use the client libraries than the REST APIs. I still would like to finish my demo. I hope it's warm now. So, please be indulgent. Oh, yes. Please upload AutoML Vision. So it correctly inferred Wallace with high confidence, and maybe none of the above, but 18% is below threshold. Maybe Gromit, but really not. Okay, let's try with another picture. It should be faster now. I do hope so. This is Gromit, high confidence, 99%. This is great, I love it. Then, the two on the same picture. Oh, it correctly inferred Gromit with high confidence, and it correctly inferred Wallace with confidence 71% above threshold. So it did work. I mean, with a threshold of 50%, the prediction would have been correct, so it's fine. Also because I trained with a lot of pictures featuring both Wallace and Gromit, it's important, and it turns out I also have my label none of the above, which should be useful for my last sample. Okay, let's see, none of the above with high confidence. Well done, Google Cloud Platform, AutoML Vision. Okay, back to the slides. So let's sum this up. Building a picture classifier, it's easy already. I really enjoyed using all of these tools because you don't have to be a data scientist to do that. You don't have to be very proficient in many specialized programming languages or libraries or framework. Most of the automatable work is now automated. So this is really enjoyable, and this is why this talk is classified beginner. Any of you can try it right away. You just have to gather a few hundred pictures and enjoy the inference. And the takeaways here that you still have to gather the data and cleansing. Cleansing is an English verb meaning pre-processing the data. It's a huge part of the job, meaning a lot of work. I'm sorry, this is not automated. My advice is to design actionable labels, meaning when you get a prediction, you have to know what to do with this prediction. If it's just saying this is the sky and this looks like a parachute, then it's not always that useful. And because it's straightforward to test, you will know very early in your project if it fits your need or not. For the accuracy, for the speed, just try it. It's easy. I hope I give some of you the feeling like that you will try it because it's fun to do and it's really straightforward. Thank you for listening. There is another AI session this afternoon at 3:30. It's about innovation and culture by Uttam Tripathi. And oh yes, these online resources on AutoML Vision are great. Some talks by Sarah Robinson. And this guy is Yufeng Guo, and what he did, it was brilliant to build easily some data sets, like how do I get hundreds or thousands of pictures. It's easy of my object. I just take a video. Okay, I take a video, various angles, various lighting, etc. Then I just use FFmpeg to cut every frame. Every frame become a sample photo of the input, and I get a nice model with that. I really like the video ID. It's great to quickly come up with a data set. That's it. Do you have questions?
Actually, we don't have time for questions.
That's too bad.
Time's up. Thank you very much, Valentin. Here also your chocolate, but I'm sure that if people have questions, you can approach him.
Definitely.
Don't forget the Ernie Lounge is still open. The coffee machine is there. Have a drink there. And thank you very much again.
Thank you.
Oh.